Okay, so next is empirical formula and molecular formula. Empirical formula and molecular formula. What is empirical formula? Empirical formula is the simple way of representing a molecule. It's not the actual way. It might not be the actual way. It can be the actual way also, but it might not be the actual way. But a simple way, and molecular formula is representing the molecule in its actual way. In a molecule, what is there? The atoms are there. Now, how many atoms are there exactly present in a molecule? What is the constituent of it? I told you what is chemistry. That is, actual content of the atoms present in a molecule is the molecular formula. But when we are writing in a simpler way means the simple way, simple ratio way, then we are calling it as empirical formula. And empirical formula is not necessarily to be molecular formula. That is not necessarily to be real. Okay? It's not necessarily to be actual, but molecular formula is real, actual. For example, just one example can make you understand this. For example, the glucose has the molecular formula. Two examples I will take. Okay, glucose has the molecular formula C6H12O6. That's the molecular formula of glucose. Fine. So it has got 6 carbon atoms, 12 hydrogen atoms, and 1 oxygen atoms. In actual practice, in reality, and that is why its molecular formula is this. But if I take the ratio of these number of atoms of that particular elements present in the glucose, then it will be 1:2:1. That's the simple ratio, simple whole number ratio we are going to get. Empirical formula is represented by this ratio. So obviously that is not glucose. That is just the empirical formula of the glucose. Fine. So empirical formula might not be, I told, might not be same as the molecular formula. But if I write suppose sugar, okay, I'm just writing sugar. The molecular formula of sugar is, I'm taking little bigger molecule, okay, sugar is C12H22O11. Now can you get anything common over here? You can't get anything common over here. In between 12, 22 and 11 nothing is common. 12 and 11 something is common. 12 and 22 something is common. But in all these three nothing is common. So the ratio of this, the simple ratio of these three will be also 12:22:11. In this case, the empirical formula will also be C12H22O11. Yes, so there is no difference in this case. There is no difference between the empirical formula and the molecular formula. But in this case, the empirical formula and the molecular formula are different. That is what I told, that empirical formula might or might not be the real formula. Okay, when it is real formula, when it is not. For that we have to know the relationship between empirical formula and molecular formula. And the relationship for empirical formula and molecular formula is this. Molecular formula is equal to empirical formula into n, where n is a whole number, positive whole number. Okay, n can be a positive whole number. Molecular formula is equal to empirical formula into n. N is a positive whole number. That means it can be 1, 2, etc. whatever. Now if n is equal to 1, suppose if n is equal to 1, then molecular formula equal to empirical formula. In this particular case, the value of n is equal to 1. In this particular case, the value of n is equal to 1. That is why the molecular formula is equal to empirical formula. Okay, but it is not necessarily that n has to be 1 always. Only in case of n is equal to 1, the molecular formula and empirical formula does not have any difference. Okay, but if the value of n is something else excepting than 1, then obviously there will be difference in the molecular formula and empirical formula. In the previous case, in case of glucose, you see, if you multiply CH2O, that is the empirical formula, by 6, what we are going to get? C6H12O6. So here the value of n, in case of glucose, what is the value of n? The value of n is nothing but, what? Nothing but the 6, okay, in case of glucose. Now how to find out the value of n? I told 6, but how to find out the value of n? It's very simple again. The value of n can be found out from molecular mass, dividing it by empirical formula mass. See, let's find it out for glucose. What is the molecular mass of glucose? Let us just find it out. What is the molecular mass of glucose? Because already we know what is molecular mass, how to find out molecular mass, we know it, okay? Molecular mass, what is the molecular formula of glucose? C6H12O6. So let us find out the molecular mass. That's 12 into 6, okay, 6 into 12 or 12 into 6 plus 12 into 1, this is 1 into 12, okay, plus oxygen how much? Oxygen is 16, yes, so 16 into 6. 6 atoms of oxygen are there, 16. So that much AMU is the molecular mass, right? That much AMU is the molecular mass. So what is the molecular mass? That is 12 6 are 72, yes, plus 12 plus 16 6 are 96. So that is equal to how much? It is 84 and 6, that is 84 means 180. I think 186 to 8 and 2 10. 10, this is 9 and 1 10 and 1 11 and 7, yes, 180. 180 AMU is the molecular mass of glucose. Fine. Now, what is empirical formula mass? What is empirical formula mass? What is empirical formula? We already know, CH2O. CH2O is the empirical formula. So what is its mass? Its mass is, C means carbon is 1, that is 12, 1 carbon atom 12. Hydrogen is 1 into 2, 2 hydrogen atoms are there, and oxygen is 16, you know. So that is equal to how much is 12 plus 2 plus 16. So that is equal to how much? 12 plus 2 is 14. 14 plus 16 is 30. So empirical formula mass is 30. Molecular mass is 180. So what should be the value of N? Molecular mass 180. Empirical formula mass 30. So what is the value of N? It's nothing but 6. Did we get that 6? Did we get that 6? And that is why the molecular formula is equal to empirical formula into whole N. Okay. Now we will solve a numerical where the percentage composition is given and we have to find out the empirical formula, and molecular mass is given, then we have to find out the molecular formula. So please note down the question. Note down the question that in a compound, the percentage composition of carbon and hydrogen, the percentage composition of carbon and hydrogen are 80% and 20% respectively. The percentage composition of carbon and hydrogen are 80% and 20% respectively. Calculate its empirical formula. Hope you understood what is empirical formula. Now I will show you that how to find out the empirical formula from the percentage composition. Okay, and I am going to show you in the most easy method, a tabular method, and you are going to follow that method also. It's not that I am going to tell you some technical things, some whatever you call, this very theoretical thing. No. Okay, in a tabular form only I am going to show you, and you are going to perform this on. Fine. So we are going to make a table. The first column of the table is elements. That's the first column. Okay. Now, what are the elements that is present in your compound? That told you carbon and hydrogen. I just wrote carbon and hydrogen. Simple. Carbon and hydrogen. Okay. Fine. Carbon and hydrogen. Next one, we are going to write percentage composition. So that is also given to us. What is given? This is 80%, this is 20%. It's given to us. Okay. Whatever is given, we are going to write it down. Then next we are going to write atomic mass. Next column is atomic mass. Next column is atomic mass. Okay. So these are the columns we are going to do. Atomic mass. What is the atomic mass of carbon? We know what is the atomic mass of carbon? 12. And what is the atomic mass of hydrogen? 1. Okay. Next one we are going to write, next column we are going to write relative atomic mass. This is just information, few informations we have written, nothing else. Okay. Next one I am going to write the relative atomic mass. Relative atomic mass. How to get the relative atomic mass? Relative means relative to one another. Carbon and hydrogen ka interrelative atomic masses is 1. How to get the relative atomic mass? Just by dividing the percentage composition by atomic mass. Percentage composition by atomic mass of that particular element. So 80 divided by 12. 80 divided by 12 is the relative atomic mass for carbon. So 80 divided by 12 is how much? Just do it. How much you are getting? 6 12s are 72. Again 80 is coming. Okay, so 6.6666 it will come. Okay, so I am writing 6.67. Okay, 6.6666 it will come. Right? So I am writing it as 6.67. Fine. What is the relative atomic mass of this? 20 divided by 1. 20 divided by 1. So that is equal to 20. That is equal to 20. Okay. Next column we are going to write. Next column we are going to write simple ratio. Simple ratio. Okay. What is simple ratio? How to get the simple ratio of these two elements? Now you got the relative atomic masses 16.67, 120. Fine. Okay. Now whatever value you got, here I have taken a very simple one with 2 elements. It can be more than 2 elements also. Okay. So that you will do once more one you will do. But these two ratios are there. I mean these two values you got. You have to divide both of them by the smaller value. By the smallest value if more than 2 are there. That is how we are going to get the simple ratio. So out of 6.67 and 20, 6.67 is small. So to get the simple ratio, we have to divide 6.67 by 6.67. So we are going to get it over here 1. 6.67 by 6.67 is what? 1. And the 20 by 6.67. If you divide 20 by 6.67, you will get it as 3. You will get it as 3. Okay? Fine. So that is a simple ratio. Here already we got these numbers as the whole numbers. If we don't get this as whole numbers, one more column we have to write, where we have to write simple whole number ratio. Where we have to write, let me write it over here only, because in certain cases you won't get this as a whole number. So it is simple whole number ratio. So simple whole number ratio also over here is 1 by 3. Again 1 by 3 because already we got the simple whole number ratio. Okay, and hence we can write the final column, the empirical formula. Empirical formula is what, you know? C how many are there? 1. H how many are there? 3. So the empirical formula will be CH3. Empirical formula will be CH3. Okay. Now hope you understood that how to find out the empirical formula. Now just continue the question again. Just one more line you write down the question in the question itself. Okay, just go back and write down in the question itself. If the molecular formula, if the molecular mass of the compound is 30, if the molecular mass of the compound is 30, comma, calculate its molecular mass, calculate its molecular formula. Okay, or write down its molecular formula, calculate its molecular formula. Okay, now what do we know? Next, so up to here you have written this is understood, this is completely understood. Now the next thing is that now we know the empirical formula. From there we have to find out the molecular formula. Now what is the relationship we know? The relationship we know is that molecular formula is equal to empirical formula into n. Molecular formula equal to empirical formula into n. We are going to write it like this. We know molecular formula is equal to empirical formula into n, that we know. So to know the molecular formula, we already know empirical formula. To know the molecular formula, we must know the value of n. Now what is n? That also we know. N is equal to what? Molecular mass divided by empirical formula mass. Molecular mass divided by empirical formula mass. What is molecular mass? That's given in your question. That is equal to how much? Given 30. It's told 30, yes, 30. Now we will find out the empirical formula mass. What is the empirical formula mass? Let's find over here. Carbon means 12. Hydrogen means 1. So 3 into 1. That is equal to how much? 12 plus 3. That is equal to 15, right? So empirical formula mass is how much? 15. So what is the value of N? The value of N is 2. 30 by 15 means how much? 2. So if the value of N is 2, what is the molecular formula? The molecular formula should be equal to, what is empirical formula? CH3 into 2. Yes, CH3 into N. So that is equal to how much? That is equal to C2H6. C2H6 is your molecular formula. So hope you understood that what is empirical formula, what is molecular formula, and how to find out the empirical formula, molecular formula. This is all about the theory of this first chapter. Theory of the first chapter. We are going to solve the questions now. Okay, then I'll come to that.